Good day, everybody. Welcome to the stream. And today we're going to research another game engine in the Rust ecosystem. And I got this referred to by a guy called Vader, who's probably the creator of these engines, of these game engines, and they look really promising. A bit like Quicksilver, but they look even more minimalist. They're not that widely known, at least I couldn't find them online, and they're called Miniquad and Microquad and Good Web Game. And as I understand it, there was this great engine GGEZ, and this GGEZ was primarily made for games on the desktop, but I'm looking for Wasnt Game Engine, and so let's dive in. So this is I just asked the community. There's this really nice Discord channel where you can get like a whole group of people who are working on games and graphics, and I asked him for some advice, and I said thank you for your advice. Cool. And it's really nice, you know, to have this community that helps you. So yesterday I started looking at it and they look really promising, really cool as well. So and it's updated recently. So let's just try to get some of the examples running. So let's go through it. Like a safe and cross-platform rendering library, focus on portability and low-end platform support. So it is highly inspired by so-called GFX, so-called overview, and implementation influenced by Crayon. So I'm going to read them both for more in-depth understanding. But let's just like go and see some of the examples, and you can see like a lot of really cool stuff already built in it, and it works, and it compiles to the browser. So for example, if I open this example, we have like a nice Wasm cube in a cube running, and this really reminds me of the old demo scene, right? So it's really cool. All right, so let's just see and check out this our third engine in the series. So git clone Miniquad. So here we go. Here we have Miniquad, and let's see how everything is structured. So we see everything neatly defined in. We see like a complex cargo YAML file, which has like multiple dependencies, multiple targets. They use SAP for essentially having the cross compilation working. It also has an Android target, which is amazing, and it has a Wasm target. That's something I really like. And they have a few dev dependencies. There's Glam and Quad Random, which I both, we can look at them both. A log implementation. So I don't see many dependencies at all in this cargo YAML file. So we have native, and for example, let's look at SAP Darwin. And we see another cargo file which uses the Socal app. Exactly. So now we have here, it's a separate package, right? It's a separate package called SAP Darwin, and it's on libc and it's built on CC. It's interesting. Eh? This I encountered this CC dependency earlier. I wanted to look at it. So Rust CC is so there's a way essentially to build C files, exactly. So this probably will have like a build, exactly. There's a build thing. So what does this do? External Sokal app m, try get compiler, unwrap or else panic. Sokal debug, so let's say debug flags are enabled. And we have two linked libs, like Cocoa and OpenGL. Okay, very interesting. So let's look at the source. We have a GLRS, which is bindgen generated. We have a lib, which uses the app Darwin, the GL, and he put the bindgen in there and the module rand. This all looks really clean code. Includes Sokal app.h. And again, so these are all bindings to Sokal. And external, we have Sokal here. And this is app and h, and this is, so essentially this is all built on Sokal. I've not heard of this before, so let's see what this does. So Sokal is a minimal cross-platform standalone C headers. So these essentially are cross-platform headers to compile to different kinds of platforms. So I'm going to make a note of this in my book. Let's say in my research log. So it's like okay, so Saturday, looking at micro. Okay, that's this. Which is combined into this. Okay, so now we know that this is the case. We have like different kinds of things. So let's go into external, and we have Sokal, and here essentially like it has different kinds of bindings. And this was, for example, the Darwin, and let's say, for example, Linux. It also has a TOML, uses libc bindings, and the build is links against GL, XLF, and things. Okay, cool. Makes sense. And we have the Wasnt, which we are interested in. So part of the Miniquad rendering library, bringing, binding, and the implementation for GL and Sokal APA. Okay. And this doesn't have a bindgen. Cool. So here we have some kind of very big file which has all kinds of stuff in it to work with SAP to Wasnt. Did the SAP also had something so called? Also had Wasnt. Live samples via Wasnt. Wow. This looks pretty cool. This looks really cool. Debug text. Okay, so a lot of stuff already is built here. It's really cool to see this running in the web. Nice. Okay. So it's built essentially on Sokol. Okay. Let's go back. So what is SAP? Let's see the TOML file. SAP Windows. This is really clean, eh? So there's almost no dependencies. That's amazing. I'm really curious how fast using this Miniquad it is to essentially compile, like an example. Because that was something I didn't like about the Amethyst library. Because there like you had to, it was like a big system, you know, and I don't like that. I just want to have something really specific. So let's look at the examples. How stuff is implemented. Let's see. They also have an examples index. So this is the off-screen. Maybe it's interesting just to open. So let's get this one. Open this examples library. Let's open this thing. Probably need something else. Let's look at the examples. Let's say this cube, right? How is this structured? Off-screen shader, display shader, main. So it is like a start function, which takes a default configuration. This is just the default, and what is the conf? So the default settings for this library is no caching, no loading, window title is empty, 800 high DP, everything is false. Okay. And then we get a mutable context. Then it does something with user data owning. So it's this user data owning. We have an event handler, which has a lifetime of static and a context. This context is moved in. And it returns a user data owning with a boxed event handler, with again the context owned in. So owning is essentially a tuple of this event handler and a context. So this is essentially a trade object, right? Trade object and a context, which is owned in the user data. Okay. And again, there's an event handler. And that's the stage. So the stage is the event handler, and it takes a mutable bar of this context. It takes a mutable button and returns the context. So this new does a mutable borrow. Stage new, yes. So what does this do? Oh, this is already the, okay. This is the event handler, right? So we get a mutable bar of the context. We say okay. We do a new render texture with some texture parameters. We have depth image. Is also a texture image. Then we have an off-screen pass, which is a render pass. This is where this is in the Miniquad library. So we're really low level here, right? And we have here the different vertices. And then we have here an immutable buffer of this context. Interesting. Immutable. So here we are already going to buffer type, value size of val, unsafe. So here we're entering unsafe. Gen buffers is where now we're essentially in the native. Now we're entering the native implementations, right? So this is sep wasm. So now we're essentially in the native bindings. This is all in here. This is really cool to see how we implemented this. So here we have GeoGen buffers, which is then also implemented in the Wasm, and this is in the Wasm, yeah, exactly. The JavaScript here. This one I want to see. This now this has a Glen object, which is on different prices. Okay, textures, we have different versions here. Okay, textures, exactly. This all runs to the same. So where is this implementation? Create function, GL, buffer. So this is how this engine calls into the Wasm, or let's say uses like in the Wasm calls to essentially JavaScript WebGL. Essentially that's how I see this a bit. And probably this is the case. Okay, very interesting to see how this is done. So we go all the way back. So this is a pretty low level library, like the Miniquad, right? To make this happen. So it all builds this up, and then it builds shaders, display pipeline, and off-screen pipeline. So this is really from the beginning, right? So this is like low-level coding. This is how I see the Miniquad. So we also have a Microquad. So let's look at that one. So Microquad does something else. Microquad does Microquad is a bit more high level. So let's also export this one. Git clone Microquad. And Microquad is, let's read the documentation. Simple and easy to use game library, heavily inspired by Raylib. So now we have Raylib as an exactly. So what's Raylib? So Raylib is another like game engine. Microquad attempts to avoid any specific Rust programming concept like lifetime borrowing. It's very friendly for Rust. Okay, so let's see it in action. Let's see one of the examples. So Arkanoid is implemented using this. So Microquad, let's look at the examples. Let's do Arkanoid. So it's also interesting to see, essentially. I think, we can of course try out some of these examples, right? I think it's wise to do. So let's quit this one, open a new one. Microquad is now. So cargo run example Arkanoid. So let's see. Just debug build, huh? With everything, and it is already there. Wow, this is fast compilation. This is pretty impressive. Perfect to start experimenting. We have like a fully functional game already. It's a bit that's crazy. It's a bit light on the touch, but it's playable. Interesting. Okay. Oops. And this probably also compiles to Web10. But just to see essentially how fast it compiles from nothing to example is boom. So this is what you want, right? You want to have like a fast flow. So that's pretty amazing. So let's see how this is implemented. We have blocks, screen width, height, we have blocks, we have a camera. And then we have a game loop, which is pretty simple. Clear bound, clear background. And then it's very functional, is key down. Then platform X is plus or min, minus. Of course, very how to call it. I think it's a lot of there's no. That's also why it felt a little bit light on the touch, because it's not managed essentially, right? So okay, so the stick is false, the ball X and the ball I, delta I, else draw text. Yes. Oh yeah, so sticks. Yeah, then it sticks to the ring, and otherwise draw text. Ball X is platform X, ball I is this. Stick is not ski down. It's a very simple implementation, but it shows exactly what it is, right? So the ball, to summon the ball has to be drawn, right? It's okay, it draws these blocks. And that's this thing, there's a draw rectangle, that's perfect. And then here we have a draw circle. Ball X, ball I. And we have a draw rectangle. That's the platform. Purple, and then next frame await. So this is an async function. Async main, and you give it a name with a procedural macro. Pretty impressive. Okay. And let's see another example. Let's input keys, Rust, shaded toy, test window, texture, tree. That's a tree. Let's run that one as well. Tree. Wow. Amazing. Cool. Okay, this also works. So then we have even a higher abstraction level he created, and that's a good web game. I'm gonna add him as a Twitter. He did some great work. Follow. Made a game. All right. Impressive work. So now we have like a good web game. Minimal 2D game framework for Wasnt. So this is then again, let's say a higher level. So we have Miniquad, and normally you have let's say good web game in your game, and then SAP consumer, and it's SAP. What is this SAP? Is this something that already exists, or is it something he invented himself? SAP, Rust. And these are crates. These are independent crates. So created those crates. What is this? Oh no, it's part of the Miniquad rendering. Okay, so he made this as a binding and yes implementation of the so-called API. Cool. So this is made by him in the public domain. Cool. Okay, so these are different. So he made this as an app. Okay. So now we're at the other level. So that's then the good web game stuff. So let's copy this one. Let's clone this one as well. Surprising. So Microquad, and now we have Microquad, Miniquad, and now we have the good web game, which is a variant again of this. It also has examples, so let's look at how this is implemented. Let's do Astro Blasto, I don't know. So good gain is now can be, yes, okay. It's trivial but still cool. So let's do it. Let's cargo run example, and we do Astro Astro Blasto. Ah, I'm the wrong one. Web game. Oh. This is my and we have to wait essentially for my editor to be ready with indexing, but we can look already at the code. So we have here a little bit more high level. So point 2, point vector 2, random vector. Okay. And this is what I like, you know, because it doesn't force you into actually making, like using this entity component system that Amethyst has, but it allows you to create it essentially as we go along. So here we have like an actor type, another actor, and we have a player live, shot live, rock live, player, beatbox, max, okay. Interesting. So it's like a minimal ECS, which we have like a player, rock, and shot. Struct actor. Actor type. There's a position. This would normally be a component. It's facing, velocity. Okay, cool. So is it done already? Oh, here we get some errors. Interesting. So what is the problem? Error. So what is the problem? Use of unstable feature recently added. So it needs this feature to be created. Does it need it here? Where's the main? Where's the lip? But it's somewhere else. Yeah, the error is in the Amy GUI. Do you already see like a lot of? Oh, here also an error. Yeah, that's because I added. So I need to remove this. Lip. Let's just quit this. Yeah. Building. we got a working version. Very cool. Oops. This is pretty cool. Okay. Beautiful. Okay, let's stop this. And we got the working version, but this has to be stable. So this has to be compiled and stable. This good web game. But it's definitely like a bit more. A bit more high level. In the sense that we have here player, actor type, point. So create rock, create actor. I'm just looking at the structure, how this is implemented. So handle input. So we have the I-axis as a trust. So only on the I exactly. Player trust, direction. Update actor position. Delta time. So these are all these are essentially systems over the actor in this case, these functions, because they all take an actor and they mutate them. So world to screen coordinates. Okay. Translate audio testing tool. Audio system. Assets. Now it becomes interesting. So you can define images to be stored. And then they have to be loaded, of course. So these are fail. So these can fail essentially. So let's see where this is implemented. So file system open, blah blah blah. And it returns bytes. Okay. So what does this return? An image. Self image from RGBA. So it wraps it around the struct, but essentially we have the individual bytes here. Same with the font. Probably do the same thing, but this is blocking probably. So implement assets. Shot sound, hit sound. Sounds is not included. And here we have an actor image. Oh yeah, it's based on the tag, you know, the image is here. Okay, then we have an input state. The default for input state. And now we have the main state. Okay, so now we get to the interact actually game do. Exactly, the main state is our game's global state. It keeps track of everything we need to actually run the game. Our game objects are simply a vector for each actor type, and we probably mingle gameplay state like score and hardware state like input a little more than we should, but for something this small it hardly matters. Exactly. So we have a player, we have shots, we have rocks, we have different levels, we have assets, we have the screen width and height, input state, and player shot time. Cool. So this is the new So here it initializes everything, but it also gives back a game result. This game result is this in source error. Okay, so it's part of this library. And game error is defined as either an IO error, a Leon error, like a TTF error or an unknown error. So yeah, okay. And we have here like print instructions. Okay, what is this? Oh yeah. And then we have assets, create player, create rocks, width and height, drawable size. This is this function from the library. Just assign that the window underlying drawable in pixels as with height. Okay. So the width and the height. So we convert it here as F32s. Okay. And then here we have some events. Fire player shot. That adds this shot to the state, so it can essentially start animating. Clear that stuff. Exactly. Shots, obtain, rocks. So these are all actors. Handle collisions. Okay. Check for level respawn. Check. Update UI. Print instructions. Okay. Draw actor. So now the event handler trait, exactly, from GGEZ events, which provides GEZ with callbacks for updating and drawing our game as well as handling input events. Exactly. So now we say, okay, implement an event handler, and then we go. So we do the update gets the self in the context, mutable self, check update time. This is probably also from the library. Timer, exactly. And here we have seconds. Handle input. Player handle input. Takes your input state. And he got this from the self input. So this is something probably handled in the engine itself. I don't really understand this. So self player shot timeout milliseconds. Yes, then. Give shots. Self input here. Is this it's defined here, right? Input state. So this is probably then updated inside the library, because input state default is from is defined here. Interesting. So maybe it's somewhere else, I don't know. Draw, update, key up, key down. Oh, okay. Now I see it. Okay, so these are all events, right? So this is an update, right? There's an update loop, handle clear, check for level. Exactly. Then we have the draw function event. That's exactly drawing based on the state. And this goes at so it's always clear, and then loop over all objects, plot them and go. And then we have a key down event. Exactly. And we map this to our input state. That's brilliant. We have a key up event and we just release it. Exactly. We have a resize event on the window. And this is what's being pushed into this start method. of this good web game, which is a mapper of GGZ. And that means we have here, oh, that's also cool, the resources .tar to vec. So here we have somewhere resources tar. Oh, cool. It's not zipped, but we can access it as a tar, which is pretty cool. So all the resources include bytes. This is an interesting, let's say, Rust macro. Include bytes. It's from the standard library. And this is pretty cool what this does, because essentially the whole file is included at compilation time at compile time. So that's pretty cool. So it's part of the essentially executable. So it's essentially including this whole resources star. But if we look at it, I don't know, can we find it? Yeah. So here are all the resources together. Angle, background, blah, blah, blah. But the interesting is, I would like to see examples. Okay, so now it suddenly becomes part of the executable, which is pretty cool. So if you build this executable, this 1.1 megabyte is in the file, so we don't have to put that in. We don't have to put that in a separate. We don't. If we distribute it, then it's all part of the executable, which is pretty cool. So cache star. Sorry about that one. Okay. So there's a cache star. How is this implemented? So we have a cache. What does this do? So this configuration object can have a cache loading. Ah yeah, we'll try to read from this dir if there's not your file in the cache. So do I like Wasnt? Physical row dir. Oh, interesting. I'm also very curious how this works in Wasm then, you know, because there's always a tricky thing. So maybe this is like included in the Wasm file as well. That would be amazing. I want to see this run on Wasm as well. Okay, that was the mainstay. Do they have this as an example of Wasm, like the build? Bytes. No, let's remove this. Example architecture. So let's, as an exercise, let's do this extra Blasto. Let's take this and make a new file. Let's see what's Game Engine. Let's try to make this cargo new Astro Blasto. Exactly. Astro Blasto. And then we have add good web game. Yeah. Oh. I didn't have it installed in this table. So cargo add. Oh, okay, good web game couldn't be found. So how's it called? So we have this now. It is a grade, right? Or is this a grade? Good web game. Good web game grade. Wasnt. Web game grade. Oh. Good web game. Damn. Okay. So this I cannot include it as a crate, but I can include it probably as a directory. So cargo, maybe it works also like this. So cargo add game engines, good web game. Exactly. So let's see, cargo. Let's just kill this one. Okay. Now we go to source main, which essentially should be copy good web game examples Blasto to main, source main up. Now what? Okay, problems and algebra. So we also need that one. Cargo add an algebra. So now it is building. So let's execute. I'm also curious now, is that Blasto? Now we're running everything on stable exactly. So let's see if we get an output here. And if we have an output, then we can try building it to web. Once we have that, then we know we are in business. You know, it's taking a long time. Cargo build. So meanwhile, let's see how we build it. Miniquad a web version, okay. Yes, cargo build target, cargo web deploy. for mint. What is mint? Cargo add mint. Okay, build. Source resource repertoire, very important. So let's do it like example. Game engines, good web games. Example resource repertoire to source. Maybe it's another version of Miniquad, huh? It's all very alpha. So let's again look at let's say the game engines, good web game, cargo, tunnel, Miniquad. That needs a very specific Miniquad version, I see here, and features mint. Okay, so yeah, we have everything here. So I don't understand what the hell is happening. You should do it. Also Blasto, cargo build. Why doesn't it build? Deprecated item. Trade bound. Well, this is a main. I think it's because of the min or something, you know. Some cargo. Which algorithm did they use? Good web game. And 0.5. 0.5. Shouldn't make a difference. Nee. Still doesn't work. Een algebra? Op het 19. Algebra. Okay. Miniquad business. So this is important. So we need to write an algebra version. And now let's just execute it. So we do run the thing, and we got a working version exactly with all the resources and everything in there. That's pretty amazing. Okay. Now we want to have a web version of this thing. So how do we do this? So we leave here. Microquad Game. Let's go to Master Blasto. So now we need to cargo web deploy. This would be perfect. If this would work, right? So let's make some pizza. Boom. So Blasto was deployed to deploy, yeah, and now we have cargo web start, and normally let's see if this works. If this works as well, then I'm really happy. So we have here localhost 8000. But it doesn't do the trick. Too bad. Let's see what happens. Filter load a resource. Error loading. It means these GL bindings. So Wasnt. So it needs this index HTML. So let's try this one. Target deploy. We have an index. Which is different in our case, because we need these GL libraries as well. Let's see. We still have Blasto. Interesting. So I need to. Why is it still loading that one? Target deploy. Yeah, it's also a complete different way of deploying. So let's follow the guide so that thing doesn't work. So it says cargo build example quad. That's example, that's build. Target wasn't an unknown. So let's do this. As for Blasto, cargo build. And then we have target was unknown. So all different different approach. Okay, so now it's, where is it saved? Now we have a new target. We have here the target wasn't known. Debug and answer Blasto, yes, it wasn't. What does it say? Quad wasn't. It's the same thing, right? Let's see what's the difference between these targets. So we have deploy. Deploy. And there wasn't. Never do no diff astro blaster, yes. Between the other target. Debug. Astro blaster, yes. Is there a difference? No. And is there a difference in the astro blaster wasn't? They do differ. Because it is binary files. But are the sizes the same? Let's see. Interesting. Debug that one is way more bigger than the one below. But okay, let's go to the target. So we have here a target, and we need an index, film index, HTML. Then we use this one. So that's cool. Let's use this step. Basically, it's the beat server. Here we'd have like, so we only need to load the quad of the wasm here, right? With no need for the interop. It's minified in this one. That's pretty cool. So the only thing I need to do is load this thing here. Okay. When it's done, so we can stop this one. As to Blasto, target wasn't. Debug. Okay. This is only Astro Blasto. Astro Blasto wasn't. Okay. He's almost done. Okay. So it's now at 4,000. We have a black screen, but no cookie yet. Blasto. It's called Blasto, right? Blasto, but it wasn't exactly. So maybe that's the problem. Yes. Ze didn't deploy them. Even kijken hoor. Ze didn't deploy them. So copy index naar apply. Requires a callable. It's 4 megabytes. So the Wasnt being built is not in the correct format. What if we just do another deploy? Cargo web deploy. Why is it still building everything? So we have Astro Blaster. Source main target line. We got this again. Now we're running the script Astro Blaster ES. And what does this do? It's all like this. Astro Blasto Wasnt. Okay, that's the same. And then it just calls it, so this should be the same thing. Okay, so now it needs this GL function, exactly. So, fem index.html, and we also have another index. That's here. Wasnt debug. This is very important. Link. GL canvas. Exactly. Yeah, okay, so it needs a GL canvas here. So the canvas needs to be a GL canvas, that makes sense. GL canvas. There's an ID. WebGL. WebGL. Oh. The context of null. So hashtag GL canvas. GL canvas. GL canvas. Wat voor canvas maakt hij hiervan? Ja. Let's just make a canvas here. Jesus. So that doesn't work together well. Canvas. ID is GL canvas. And the canvas. So function import requires a callable. Okay, let's do this another time. Thank you for watching. If you're watching, I'm gonna eat something.